Okay, we're in Algebra 2, Mod 8. Guys, we're getting there. It's Monday, May 18th, 2020. This is our last week together. We will use Monday through Thursday with 4 more quick review of functions that we have to know how to graph as we head into next year. This Friday is kind of our last day together. Make sure you look at your Schoology Friday. I'll have a document with a nice, well thought out handwritten note clarifying everything about your final grade, when we're going to load those, makeup work, everything that's necessary to kind of wrap up the class and be done. So keep up with me this week. Monday, Tuesday, Wednesday, Thursday are last four lessons together. Friday is kind of a wrap-up day. If you did see a note from Mr. Fay and the administration, next week after Memorial Day weekend is simply a one-day catch-up, turn in any late assignments kind of deal before we submit and load all your final grades with the new grading scale and things like that. So keep up this week, Monday through Thursday. Your last assignment given to you Thursday will be due Friday at noon. And Friday the 22nd, check your Schoology document that I'll have attached. And then again, we'll clarify and explain everything you need to know as we wrap up the class, okay? All right, today, again, 51820, top left corner. We're going to focus on what's called reciprocal functions. We're going to do 4 problems on the front, just like we've been doing, and you'll have 4 problems for an assignment where you've got to do them with the procedure I'm teaching you. You're not typing these in your calculator and just throwing up some sketch that says, look, I did it. I don't have a calculator out, and neither should you. Can we logically understand what's going on, create a quick approach for accurately graphing this function? Here we go. The reason these are called reciprocal functions, notice they all have an x in them, but the x has been flipped over or reciprocated to the bottom. 3 over x, negative 2 over x plus 1, 2 over x squared, and finally negative 1 over x squared minus 4. So every time you see a function that you're supposed to quickly graph and there's an x on the bottom, it's called a reciprocal function, and we'll use this process. Watch. Off to the side, we make a quick XY table. Now, how do you know what number to plug in first on this problem or any of these problems? Okay, ready? Listen careful. The answer is you plug in whatever number makes the denominator turn into a 0. Okay, so obviously on this first problem, since it says 3 over x, what number would you plug in for x that's going to make it turn into a 0? Well, obviously you would plug in 0. Now, think about it. 3 over 0, you're never allowed to divide by 0, are you? That's called undefined. So you put UND for undefined. And what that means on your graph is that's where your vertical asymptote's going to go. It's an imaginary line that kind of divides your picture in half. So everybody draw a vertical imaginary asymptote through 0. And all you've got to do is sketch a curve on the right and a curve on the left. Notice I said a curve. It never will be a line because you're never allowed to cross this invisible wall. You rub up real close to it, but never cross it. So the procedure is once you've located that asymptote, and I know we've done this before, so let's go quick here. Pick 2 numbers to the right. I'll go 1 and 2. So I'm going to plug in 1 and 2. And plug those in. Obviously, 3 over 1 is 3, and 3 over 2 is 1.5, right? 3 over 2, 1.5. So I'm going to go, watch this, right 1 and up 3, right 2 and only up 1.5. And what's going to happen is your curve will get really close to the asymptote but never touch it. And then it'll come down and curve in this direction and eventually curve out and get close to the x-axis as well. Point is, you've got a curved shape to the right. Now we need a curved shape to the left. Now careful, don't just assume it's going to be right next to it. In fact, it's not. Again, here's my invisible wall. So what two numbers would you pick to the left of that wall? You would pick what? -1 and -2, which would create what two y coordinates? Well, 3 over -1 is -3, and 3 over -2 is -1.5 or -1.5. So actually, I'm going to go left 1 and down 3, left 2 and down 1.5, connect this up closer to the invisible wall, and then this will curve out and get closer to the x-axis. And usually you end up with two curves that look like twin brothers, okay? All right, block 2. I'm gonna make me a table. Careful, everybody listen. Just because I plugged 0 in first over here does not mean I'm going to plug 0 in here. Remember, what did I say? You want the number that turns the bottom into a 0. So I actually would plug in -1. -1 plus 1 gives me a 0 on the bottom, and anytime you divide by 0, that's undefined. So when I draw my picture, my asymptote is over at -1 this time. So I draw an imaginary line through -1. And again, I pick two numbers to the right of that line and two to the left. What two numbers would you pick to the right? 0 and 1. Agreed? What two numbers would you pick to the left of that line? Well, we might as well put them in there now. It'd be -2 and -3. And now go plug them in. When I plug 0 in for x, 0 plus 1 is 1. -2 divided by 1, -2. Plug 1 in for x. 1 plus 1 is 2. -2 divided by 2 is -1. So to the right of that dotted line, I've got a dot on 0, -2, and another dot that's what? Right 1 and down 1. Connect them up with a curve, not a line. It's a curved shape that again gets close to the x-axis and close to our dotted line. To the left, if I plug -2 in, -2 plus 1 would be -1. -2 over -1 is 2. -3 plus 1 is -2. -2 over -2 is 1. So that curve ends up above the x-axis, correct? Because I'm going to plot my points, left 2, up 2, left 3, up 1, connect them up, and again, there's his twin brother on that side. Not hard, just take your time and do the math right. All right, you go to the third one here. Once again, it's a reciprocal function. And even though it's x squared, you still use the same logical approach. What number would I plug in that would cause the denominator to become a 0? Obviously here it would be 0, wouldn't it? Because what's 0 squared? 0, and 2 divided by 0 is again undefined. So my asymptote is going to go right through the x-axis, through the y-axis, through 0. Pick two numbers to the right, it'd be 1 and 2. Pick two numbers to the left, it would be -1 and -2. Let's go plug them in. Plug 1 in. Careful, what's 1 squared? Isn't 1 times 1 going to be 1? And 2 over 1 is 2. Plug 2 in for x. 2 squared is what? 4. And 2 over 4 is actually 1/2. So to the right of my asymptote, I'm going to go right 1 and up 2, right 2, up 1/2, and got a curve that looks like that. This is pretty easy. You should be good here. Now careful, when I take a negative number and go plug it in and I square it, you're supposed to know this, right? What happens when you square a negative number? It becomes a positive, doesn't it? So -1 squared is still going to be what? -1 times -1, which is 1. And 2 over 1 gives me 2. When I plug -2 in for x, -2 squared is what? Positive 4. So I have 2 over 4, which is again 1/2. Oh, so left 1 up 2, left 2 up 1/2. Connect those up, And I do have two curves that are, again, twin brothers, but both of them are above the x-axis this time and are reflections of each other. Okay? Finally, the only time it gets a little tricky, I'm going to make an XY table here. Okay, I'm going to give you a second to think about this. What number would you plug in for x that would cause the bottom to turn into a 0 on this problem? Wouldn't it be 2? Stay with me. What's 2 squared? 4. And 4 minus 4 would give me 0 on the bottom, so that's undefined. However, wouldn't negative 2 also do the trick? Think about it. If I took negative 2 and squared it, I still would get 4. 4 minus 4 is still 0. And I'd be dividing by 0 and get undefined again. So unbelievably, this picture is going to have an asymptote at 2, but also an asymptote at negative 2. So I'm going to go right 2 and draw one dotted line, left 2, draw the other one. Now watch this. Give me two numbers to the right of 2. Wouldn't you pick 3 and 4? Now stay with me when I plug 3 in. What's 3 squared? 9. Minus 4 is 5. So I'd have negative 1/5. Agreed? Plug 4 in for x. 4 squared is what? 16. 16 minus 4 is 12. So that one's only negative 1/12. So guys, watch. When I plot those, I'm going to go right 3 down 1/5. That's not very far. But right 4 and down 1/12 is even less far down. So when you connect those two up and make a curve, it steeply starts to curve and go next to the invisible wall and next to the x-axis like that. And think about it. When I go over here to the left of the other asymptote and plug in negative 3 and negative 4, won't that produce the same two answers that 3 and 4 did? Because they're getting squared anyway. And when you square a negative, it turns into a positive. So guys, negative 3 is going to give you the same answer as 3, which was negative 1/5. Negative 4 will give you the same answer as 4, which is negative 1/12. So I'm going to go left 3, down 1/5, left 4, down 1/12. You end up connecting those up and getting a curve that's the twin brother of that other guy way over there. So the final question that remains is, what do you do in between the dotted lines? Well, we need to draw a picture in there. So if I look in between here, don't I have three numbers, negative 1, 0, and 1? So unfortunately, we got to plug those in. Now don't panic. Watch this. When I plug negative 1 in for x, what's negative 1 squared? That'd be 1. Minus 4 would be negative 3. And negative 1 divided by negative 3 is positive 1/3. Obviously, when I plug 1 in, I would also produce positive 1/3. When I plug 0 in, what's 0 squared? 0 minus 4 is negative 4. Negative 1 divided by negative 4 is positive 1/4. So watch this. I'm going to go left 1 and up 1/3. Right 0, but only up 1/4. Right 1 and up 1/3. So if you look in between the dotted lines, it looks like we got a smiley face. Isn't that amazing? Our curved function, our reciprocal function, looks like that. So the last one, you got to be careful and focus on how your numbers line up when there's two asymptotes, okay? Great job. If you look on the back, 518, these are your 4 homework problems, so you might want to hit pause and copy these down. They will be due, of course, by tomorrow, Tuesday the 19th at noon. I got to have a table. You're not just typing these into your calculator. These are done by hand. The goal is to quickly and accurately sketch these functions as you move forward into next year, okay? Negative 1 over x, 3 over x minus 2, negative 2 over x squared, and 2 over x squared minus 9. That's the one that'll have 2 dotted lines, and you be careful on him. They all mimic the 4 that I just did. So if you get stuck, just look at the notes you just took, and it shows you how to work your way through those problems, okay? Great job. I'll see you tomorrow.